Trick 2. Find number of isomers. Number of isomers if from molecular formula. From MF. MF means what? Molecular formula. This is also very important. Before going to this trick, we need some basic points. Number 1. First basic formula is, this is the CH3, CH2, CH2, again CH2. 4 carbons alkyl. 4 carbons alkyl, how many possible? Total 4 possible. One is N-butyl. Second one is isobutyl. What is the isobutyl structure? You must and should remember. Iso means this is iso, same methyl groups. Iso means same. Methyl groups attached to 1 carbon. And butyl means 4 carbon. This is isobutyl. Next, secondary butyl. Secondary butyl means what? CH3, CH open bonded secondary carbon. CH2 and CH3, secondary butyl. Next, tertiary butyl. Tertiary butyl means what? CH3, CH3, again CH3. So total how many? 1, 2, 3, 4 butyls are possible. Next, propyl groups, and with 3 carbons. Number 1, see that. Number 1, CH3, CH2, again CH2. What is this name? N-propyl. Second one, isopropyl. CH3, CH double open bond, CH3. So it is isopropyl and propyl. Only 2. This is. But with 4 carbons. With 4 carbons, how many? Total 4. This is required. These 2 basic points required. Third point is number 3. This is very simple. Number 3. With ethyl. Ethyl means what? CH3, CH2. Only 1. That's all. These 3 are the basic rules. If you want to find the number of isomers with IUPAC names also. You want to find the number of isomers from molecular formula. What is the first basic rule? With 4 carbons. With 4 carbons, how many alkyl groups? 4 groups only. That is N-butyl, isobutyl, secondary butyl, tertiary butyls. Next, with 3 carbons. With 3 carbons, how many alkyl groups? One is N-propyl, another one is isopropyl. Next, with 2 carbons, not possible. Only 1 ethyl group, simple N-ethyl, normal ethyl. So these are the first basic rules for molecular formula. Now we enter into the examples. First example, very most important molecular formula given. Molecular formula C4 H10 O. For this one, number of isomers, generally structural isomers. Structural isomers. See the trick to how to find out this. 4 means 4 carbons. We know that 4 carbons, C, again C, C and C. This is satisfied by alcohols, so OH. Now you can try this. Here how many hydrogens? 2 hydrogens. Here how many? 2 hydrogens. Here how many? 2 hydrogens. Here how many? 3 hydrogens. So 3 plus 2 5 plus 2 7 plus 2 9 plus 1 10. Number of hydrogens only play important role here. 10 hydrogens. Or carbons, 1 oxygen, aldehyde also possible. But you can cross check, molecular formula not satisfied, aldehydes. So 4 carbons aldehyde you write down 1, CH3, CH2, again CH2, CHO. Main important hydrogens only here. How many carbons? 4, oxygens 1. Okay, C4 oxygen 1. But hydrogens 3 plus 2 5 plus 2 7 plus 1 8 only. But here 10 hydrogens are there. So aldehydes no. Alcohols yes. Alcohols are possible. You now see that. In the alcohols already I explained. This is which alkyl group? 4 carbons alkyl. According to 4 carbons alkyl, how many alkyl groups are possible? Total 4. That is what? One is N-butyl carbon chain. Another one is secondary butyl. Second one. Next isobutyl. The next tertiary butyl. So here N-butyl is completed. This is N-butyl. One isomer. This is one alcohol. The next isomer is second isomer. You write down secondary butyl. Secondary butyl means what? CH3, CH, and this is the OH and CH2, CH3. Secondary butyl alcohol. Third one, isobutyl alcohol. Isobutyl group also possible. So isobutyl, CH3, CH, CH3, again CH2, OH. This is isobutyl group. Fourth one, tertiary butyl alcohol. So CH3, CH3, CH3 and OH. So 4 butyl groups I can round up with C here with a green pen. This is which butyl? N-butyl. Next this is which butyl? Secondary butyl, because open bonded secondary carbon. And this is which butyl? Isobutyl. And this is which butyl? Tertiary butyl. So in this one all 4 carbon chains are different. These are chains different. If carbon chains different, carbon chains are different, differ. They are generally chain isomers. CI means what? Chain isomers. Okay, this is a different concept. So number of alcohols, how many for this formula? Total 4. 4 alcohols. Next, for this one alcohols are functional group isomers with ethers also. Now here I write down the ethers, number of ethers. So what is our heading? Ethers. Ethers. Okay. Now total 4 carbons. So here I write down the ether. Carbon, oxygen, carbon and carbon. So what is the second formula given? 3 carbons alkyl group. Only 2. One is one N-propyl. N-propyl. Second one is one isopropyl. So you write down another structure. This is one isopropyl. So only 2 only. That's all. The next, this is the ratio of what? 1 carbon left side, 3 carbons right side. 1 carbon left side, 3 carbons right side. 1 carbon left side, 3 carbons right side, only 2 isomers. Then 1 carbon you change here to here. So what is another ether here? 2 carbons, 2 carbons. So carbon, carbon, and here also carbon, carbon. So here 2 carbons, 2 carbons, only one, because according to our basic rule, ethyl group only one alkyl. Here also ethyl group only one. That's a total. This is one isomer only. But N-propyl, two N-propyls are possible. One is with 3 carbons, 2 propyl groups. One is N-propyl, another one is isopropyl. So 1, 2, 3. 3 ethers. Next change is no possible, because if you can change the 1 carbon to here, 3 carbons, 1 carbon, already finished. 1 carbon, 3 carbon, 3 carbon, 1 carbon, same. So what is that one? 1 is to 3, 2 is to 2 only possible with ethers. Remember carefully. So 4 alcohols, 3 ethers. That's why this is the total 7 structural isomers. This is the trick to how to find the 4 carbons alkyl groups are 4 only, 3 carbons alkyl groups are 2 only, 2 carbons alkyl groups are 1 only. That trick you can use. That is the trick here. Next molecule formula. Next molecule formula, C⁴H12O. First you decided for this one alcohols and ethers are possible. Alcohol possible and ethers possible. Structural isomers. Aldehydes not possible. Ketones also not possible, because this is only confusion point. So if you want any doubt, aldehyde why not possible? With 5 carbons, 1 aldehyde you write down. So what is that? CH3, CH2, CH2, again CH2, CHO. How many carbons? 1, 2, 3, 4, 5. 5 carbons, okay. 1 oxygen, okay. But main important hydrogens only. How many hydrogen? 3 plus 2, 5, plus 2, 7, plus 2, 9, plus 1, 10. But here 12 hydrogens are there.